All right, guys. So this is a planning question. Now, from marking these kind of things. So I work as a marker for CIE, okay, and I do notice that students really, really struggle with these questions. Okay, they hate them. I'll be honest with you. I think once you know the structure, it's actually okay. You just need to make sure that you're including lots of things. So we're told here. Let's just have a look at this, and we'll go from there. We're told here that we've got the rate of cooling, and it's going to depend on the number of layers of newspaper wrapped around a beaker. Good start. We're going to plan an investigation to find that relationship. Okay, and we're provided with a number of things: stopwatch, a beaker, supply of hot water, and several pages from a newspaper. And what we're going to do is add some equipment, make a description of the method. We're going to take the measurements, we will make them and how we'll make them as valid as possible. The variables we'll control and how you will process your results. Now, the reason that I read this bit is because to answer this question, if you follow those bullet points, you'll get at least 4 or 5 marks. Okay? You will, just by answering those points, you will get that. So please don't ignore the bullet points. Now, a lot of students, what they do is they then start to kind of write down here, and this is what I've done just to plan it out. Right? A lot of students want to plan out their work, and you'll notice actually when I show you my final version of it, I started again. I wasn't happy with the way that I started writing it because I thought actually I should do this a bit clearer. Okay, so let's do a couple of things. I think what you need to do is identify variables and go from there. So the first thing here is our independent variable is the number of layers. Okay, the independent variable is the number of layers of newspaper. We're going to add or take away newspaper. The dependent variable is the rate of cooling. It's the number of degrees per second that will cool down. Okay, then we've got CV. CV is our control variable, and this experiment is great because there are so many control variables. One of them, the volume of the water. Yeah, it should be the same volume of water every time. Another one, the time, because I'm not allowed to cool it down for 10 minutes one time and 3 minutes the other time. That wouldn't be fair. And also the initial temperature, because the initial temperature of the water will affect whether or not it cools down quickly. High temperatures cool down quicker than low temperatures. So you notice there, I've already started planning it out. All right, I'm kind of showing to the examiner I'm thinking about it. Now, examiners look at this page. Okay, and if they're desperate to give you marks, if something goes wrong on the other page, they might look at this and go, you know what, they've written that here, we'll give them the credit. Generally, marking is positive. They want to give you marks, so use the spaces that you have to do this. Let's go up and we'll talk about what my answer looks like. So you can see here, I wasn't happy with my beginning. I just didn't like it. I wasn't explaining myself clearly, so I started again. Okay, what I just wrote down was a process. So I've broken down into steps, and I suggest you do that too because it generally helps you with this. First, we're going to take a fixed volume of hot water. We're going to measure it using a cylinder. Okay, I forgot to write that one initially. I thought, you know what, I should say that. It's an additional piece of apparatus. Okay, I'm going to call that TH, hot temperature. We're going to place the thermometer in the water, and we let the mercury rise up to TH. Okay, so again, that's probably a bit too specific, but I just thought that was a nice bit of detail. We're going to start the stopwatch, okay, and we're going to measure a fixed time T. Fixed time T is constant. And then we're going to measure the final temperature. Okay, we're then going to calculate the rate of change of temperature, R. And I've said R is the difference between the temperatures divided by that time. And then we're going to repeat and calculate an average of R. Notice that whenever we take averages, whenever we repeat, we take averages, okay? If you're going to tell people to repeat the data taking process, you must tell them to take an average. Okay, now we're going to add a sheet of paper around the beaker. I've been a bit brief in my description here. I did this in about 2 minutes. A sheet of newspaper around the beaker and repeat it, keeping the temperature, the volume, and the time constant. Okay, and then we're going to repeat using more sheets of paper, at least 5. Okay, now notice here I'm not giving loads of instructions, but I could say repeat and calculate average R again, but I think as long as you mention it once, you'll probably be okay. Okay, again, there's the benefit of the doubt given that where you mention averaging, they assume that you're going to average everything. Okay, repeat using more sheets of paper, at least 5. Okay, and then record the data in a table. Okay, now what I've done here, I've written a really bad table. I didn't have a ruler available. You should draw yours with a ruler, please. We've got the number of sheets, and there's no units for the number of sheets. However, we've got the final temperature. That has got units, degrees Celsius. they look for this, okay? They really do look for you to make sure you know your units. If you don't have the correct units in your table, you will lose a mark at this point, okay? And then we calculate R, which is the rate at which the temperature is changing, okay? Well, that's temperature divided by time, degrees Celsius per second, okay? And then the one that they love, which is the graph. Plot a graph of R versus N, okay? R on the y-axis, N, the number of sheets on the x-axis. Now let's just look at what we've been asked to do, right? Oh, oops, I've gone the wrong way. Let's go back. Have I talked about other apparatus? Yeah, I got an extra measuring cylinder, right? I gave a brief description, yep. I've told them how I'm going to measure things. I'm going to measure using the stopwatch, etc. Okay. I've said what I'm going to control, and I've said how I'm going to process it. I've said that I maybe haven't been completely explicit. However, I've said I'm going to plot a table, make a table, and then make a graph. Okay, you're not expected to go into anything here. And the other thing that I've got to say is you do not have to add any data here. Okay, you don't need to come to any conclusions. We all know that if you add more sheets, it's going to cool down more slowly. We're not interested in that. We're interested in how you would answer the question. Now, one thing I would say is I've noticed a lot of these questions coming up recently. There was a brief period when they didn't, and then suddenly they're back again. So please make sure that you've had a chance to try one of these before you go into your paper next week.